So I want to find the average rate of change of f of x equals 3x squared plus 1 on a couple different intervals for number 29 and 1.2. So first things first, my first interval is 1, 4 to 2, 13. That's not even an interval. What is that crap?
Coordinates.
Yeah, that's 2 points, right? What the heck? What? It doesn't even make sense. Right? Okay, so I think if I draw a picture, it'll maybe start to make more sense. If I go over 1, how do I plot this first point again? Go over 1, right? And then up 4. Okay, so I'm scaling. Oh, I guess I need a couple spaces. So there's 1, there's 2, here's 4. Please note the x-axis scale and the y-axis scale are not the same. Don't get confused on that one. Okay, how do I get to 213?
Go right 2 and up 13.
Go right 2 and then up 13. So to get to 13, I need to go as much as I went up to 4, and then to 8, and then to 12, and then a little bit. So that's where 13 is. Dot. Right? Okay, but why did they give me a function f? I don't know. Okay, try this. What's a function on? What's a point on the graph? Yeah, it should be an x f of x pair, right? So I think that this should be this point here, 1, 4, should be 1, f of 1. Right? If you do the function f to 1, what do you get out? Yeah, you get 4 out, right? You do 3 times 1 squared plus 1. 4. Oh, cool. So that's actually a point on the graph. They just were nice enough to give me the both points, or both coordinates, right? Okay, is 2, 13 a point on that graph? How do you check?
You plug in 2 for x.
Yeah, plug 2 in for x, see if you get 13 out, right? So if you plug 2 in, you get 3 times 4 plus 1 seems like 13 to me. Okay, so there's some function going on here, right? And I don't know exactly what the graph looks like. I could straighten that out, actually, because that's a parabola, right? Kind of smushy and then shifted up 1. So there's some kind of parabola business going on here. That's basically what your f looks like. You guys with me on that? And I want to find the average rate of change. So where do I get the average rate of change? Should we do a change?
In the output over the input.
Change in the f's per change in x, right? Okay. So how much do the y's change? 9. 9 go on the top or the bottom?
Top.
Why?
It's the output.
This is the output. What do you get on the bottom? 1. Cool. So you get 9. You can see that? That's the slope of this line here. You guys see that I calculated that the exact same way I'd calculate the slope of a line? Right, I did the rise divided by the run. Cool. Right? This is not particularly new. It's different phrasing. Some of it's confusing as heck. Right? But the idea is still the same thing. There's 2 points. Find the slope of the line between them. To do that, take the rise, divide by the run. Easy peasy. So with that spirit, let's see if we can do this guy. Between j, k and m, n. Should do change in f per change in x, right? So what's the change in f? not you guys.
Change in f, wouldn't it just be n minus k?
Yes. Should be n minus k. Right, the difference in the y's? And the other one should be m minus j. Okay. Quick caveat. Yeah.
I have a question. Does it matter which order you put it in? Would it be exactly the same if you put k minus n over j minus m?
No. It does not matter. Provided,
As long as you do it in the same order.
yeah, provided that they're both in the same order. Right? So this is like finding slopes. So when you're finding slopes for lines, you need like a first point and a second point. It doesn't matter which one's which, but it does matter that you're consistent. Right? And so it seems like these guys answered, this is your second point, that's your first point, and then they did y2 minus y1 over x2 minus x1, right? You chose them in the other order. It doesn't matter at all. Right? Lines don't really care about direction. Okay, see that? Okay. How about this other dude? This last thing's confusing, confounding. What do you get? What do you do?
Same thing as the
Yeah, you guys shut up.
You're gonna have to.
Perfect. So I need the change in f per change in x, right? So what's your change in f, Darby?
F of x plus h minus f of x
Okay.
over x of h minus x, right?
Say that first bit again.
So x plus h can do quantity, I guess,
Okay.
minus x.
Cool. All right, and then I claim you can do a little simplification there.
Yeah.
What's the little simplification you can do?
Cross cancel the x's with the f. Yeah. No?
Now,
You can remove an x.
you can say x minus x is 0.
Yeah.
So let me talk about the other thing quick. So the reason you can't like grab those two things, one, that's a false cancel anyway. Right? Because to cancel, you have to have it factored out of the whole bottom. Right? In the same way that if you have 2 plus 3 over 2, right? You can't cross out the 2's
Yeah.
because order of operations says, what do you have to do first? Yeah, you have to do this stuff kind of in a grouping symbol, right? So what's the grouping symbol here? No, there's no parentheses in this thing.
Oh, I was thinking.
The addition.
Yeah, the long fraction bar is a grouping symbol, right? So you have to do the top first, that 2 plus 3, and then divide by 2. Right? You have to divide the whole result, so that 3 is getting divided by 2 as well. You can't just slash e the 2's. So that's one reason you couldn't slash e this x. The other reason you can't slash e that x is that this x is not multiplied by that symbol f, right? How is that x attached to that f? Yeah, that's f done to x. That thing may bear no resemblance at all to x anymore. You guys remember that? So don't think there's an x kicking around in that thing. You already put it through the function, it may be totally unrecognizable. Cool, cool? Okay. But you can do, on the bottom, you have an x plus h minus x. And so all told, I think you have an h on the bottom. Can I do the same thing up here and get an h up there? No, why not?
Because
Because
the
they're not
x and the h are added together before the function is done to it.
Yeah. Because you fed that x plus h into the rule f, right? God only knows what happened to it. Right? So you're left with this whole thing, f of x plus h minus f of x over h. And this guy here happens a lot. This dude is the slope of a secant line. Really, all of these were slopes of secant lines. A secant line, by the way, is the straight line between two points on a function's graph. Right? Just like I had a secant line over here. That's just a generalized secant line, and that happens to be the one that we start doing calculus with. Cool? So don't lose that thing. That part can go in your head. We'll play with that a bunch. Get you a little bit less scared of it. Cool? I do claim that we could do just a tiny bit better than that thing for this. Because what?
We have the function.
Yeah, I actually know what the function is. You guys see that? Should we spend a minute and fiddle that out? Let's spend a very brief minute to fiddle that out. So, since I have the function, I think I can calculate f of x plus h minus f of x all over h. Should be simplifiable, maybe. Okay, and this is going to get a little trippy. So how do you feed x plus h to the function 3x squared plus h, or plus 1? How were we feeding numbers to that thing earlier? What were we doing? Just talk to me.
Would you put the x plus h inside of the x?
Yeah, the x plus h should go in where the x is, right? So you should do 3 times the x plus h. And then what do I need to do the x plus h? Square the whole thing, right? And then add 1. So this dude here, all this stuff, is f done to x plus h. Another way you could think about that is you could take your function rule and just put like some kind of box in there, right? And then to do that function to something, I put the something into the box. So if I want to find out f done to x plus h, I'm going to put x plus h into that box. Make sure you throw some parentheses around it so you don't screw it up. Cool. And then what do you need to subtract here?
3x squared plus 1.
Okay. What do you need to remember? Close. Louder.
Parentheses.
Yeah, you need to remember some parentheses. Why?
Because f of x equals that entire thing.
Yeah, because f of x is this whole shebang, right? So you need to make sure you're subtracting all of f. Right? You're getting that 1 and you're subtracting it 2. You guys with me on that? And then this whole business was over
Just
h. And this part here, that guy was f of x, right? Okay, and now I could bust out some algebra skills. You guys have algebra skills? Yeah. We'll get better at algebra. Like, that's the point of the class. We're going to get way better at algebra. So, what do you need to remember to simplify this stuff?
That you have to FOIL what's inside the parentheses instead.
Yeah. You got to FOIL x plus h squared out, right? So, you guys FOIL or do you use box method?
I FOIL typically.
Okay, show of hands for people who typically FOIL. Show of hands for people who typically use a box. Okay, show of hands for people who typically screw it up. Cool. Good man. Thanks for admitting that. Okay, I'm going to show you the box method because it sounds like lots of you guys know how to FOIL. So I want to do x plus h times x plus h, right? So I'm going to do an x, h, x, h. Right, so now I have a box that's x plus h by x plus h. Right? So the total area of the box should be whatever x plus h squared is. So I'm going to cut that into these 4 pieces. Now, how big are each of the pieces? How big is this one? X by x, so it's x squared. How about this guy?
XH.
That's x times h. How about this guy? Also x times h. And this guy? H squared. And I should add all those up, right? Okay, so far I have 3 times, and you still need the parentheses, right? Because you're still going to have to distribute that 3. I got x squared, that's this guy. How many xh's you got? 2. We got plus 2xh plus an h squared. Beautiful. Nice, guys. And then you got, what else? And then there's a plus 1. And then, what can you do with that other stuff?
You can distribute the negative.
Nice. Distribute the negative sign. So you got a minus 3x squared and a minus 1. And this jazz is all over h still, right? Cool. Okay. All right, now what's my next step? Distribute the 3. Okay, so I got 3x squared plus
6xh.
6xh plus 3h squared minus 3x. Oops, what did I lose? I lost the plus 1 in there. Plus 1 minus 3x squared minus 1 all over h. Anything you can do with that?
Yeah, 2 times.
3x squared, negative x.
Okay, so 3x squared, take away 3x squared is no x squared.
And the plus 1.
And then there's a plus 1 and a minus 1.
And then the h on the bottom and the h squared.
Okay, careful. The h on the bottom and the h squared.
Oh, yeah, it's. we have
'Cause
to
there's
pull
another
out
one.
the h.
You guys see that?
Yeah,
So you need to what?
pull out the h.
Yeah, you'll need to factor out an h. I would advise, from long experience of watching people screw this up, that what you do is you do some of the simplification, all the same type, and then rewrite. Okay, so here I did a bunch of like, this thing minus that thing is 0, and this thing minus that thing is 0. Once I'm out of this thing minus that things are 0, I'm going to rewrite this. Okay, because otherwise I have a tendency to like miss one when I'm canceling. Okay, so I'm rewriting to what? I got a 6xh on the top. What else?
Plus 3.
A plus 3h squared, and this is all over h. Cool. Okay, now I can factor an h out. Like I see that there's h's all over the freaking place. So on the top, I'm going to pull an h. What are you left with?
6x plus 3h.
Good. And then this is over h, right? And now what?
And the h is equal.
Now the h is, yeah, h over h is 1, right? So you can drop that thing. So you're left with 6x plus 3h, which is a lot less scary than it was before, right? Cool. Questions, Steele?